All right, welcome back, everybody. We're going to talk Chapter 1, Section 3, Linear Functions, Slope, and Applications. So just some vocab to get us started. A function is something where we label it f of x, a little bit different than just y equals, but remember that that f of x is the same thing as a y. It's just showing us that it specifically is a function. So linear, we're going to commonly use that mx plus b. A constant function, so something that is not increasing or decreasing, it's staying constant, it doesn't have a slope. So then it's just going to be f of x equals some number that will be your y-intercept. It's just going to travel all the way across. An identity function, just for some vocab, f of x equals x. A horizontal line, like we were just talking about before, that constant function, horizontal, same exact thing. So we can label that as f of x equals b. And b can be any number and it will cross that y-axis at that spot. And then a vertical line, a little bit different, will be x equals, and I'm just going to put some number. You might see a letter there to represent that number, but it's going to be x equals a number, where a horizontal line is y equals a number, or f of x, meaning the same thing. We give you a little bit more reminders on slope right here, so feel free to jot those down or take a look, reread if you need some help on slope. And in our first example, we're going to graph each function and then state what the slope actually is. So to graph something linear that is in slope-intercept form, first thing we're going to do is graph that y-intercept. So at positive 1, big fat dot, our line will cross through there. Now our slope is negative 2/3. So I can travel down to start and then positive 3, or I could have started at that positive 1 and traveled up 2 and left 3 units. No matter what, I'm still going to get the exact same straight line. So don't be afraid of that negative. Just make sure you only use it one time, either going down or going to the left. Now, x equals, if you look back up at our notes that we just talked about, that means that that's going to be a vertical line. But the way that I like to remember it, this is our x-axis, this is our y-axis. So if we're just comparing b and c together, if it's x equals, it will cross the x-axis at that point. So x equals negative 2, I know it's going to cross there. Well, it doesn't make sense for that to go across horizontally. That has to be a vertical line straight up and down. Versus y equals 5/2, or 2.5, then I know that that's going to cross the y-axis at 2.5, meaning that that's going to be a horizontal line. So I don't remember which one's horizontal and which one's vertical. I just like to plot that point on either axis and then kind of reason through which one it makes sense to draw. For applications of slope, we're going to see a lot of word problems when we're talking about slope. So things that you might see are, it might be talking about the grade of a road. And that's just talking about the steepness. So if a road is really, really steep, we say the steep grade. If you've ever driven in the mountains, and you can see different grades of roads. It also talks about ski slopes quite frequently. And then you might also see something talking about maybe a treadmill. You're walking up an incline of a treadmill. Well, that's just talking about slope because you're staying constant at whatever incline you set. So looking at a few word problems, don't let them intimidate you. Just make sure you reason through them. So this first one right here, curb ramps provide independent access to sidewalks for those who use wheelchairs. Guidelines for the grade of a curb ramp suggest a grade must be between 5.9 and 8.3%. A federal law states that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. Find the grade of the following figure. Well, grade, like we just talked about in that application, that's really just slope. Well, slope talks about rise over run. So looking at this picture, it's rising 3 inches for every 12 inches it's running. So this is going to be a slope of 3 inches over 12 inches, which is just going to be 42. I couldn't see it on the screen, sorry. 3 inches over 42 inches. So that's going to be about 1/14, which is about 7.1%. So we can see that this ramp does fall between 5.9 and 8.3%, so it would be a good wheelchair ramp to have. All right, example number 3, another word problem here. I'll let you guys read that. If you want to go ahead and pause and read that, that would be great. But I'm going to go ahead and highlight some key pieces of information that we see in this word problem. So read while I'm doing that. Okay, so So what this guy is looking for, we want to find the average rate of change between 2000 and 2013. Well, I get a little bit confused on which one's X's and which one's Y's sometimes, so it's really helpful when we have a graph or we have a table, we can just see them very clearly. So I can see that the X-axis right here is years. So I know the X's are representing years and the Y values in this case are representing number of participants. That way, when I'm going to take the data that's highlighted first in that sentence, I know that it's going to be the Y values divided by the X values. So, just a reminder on slope here, an average rate of change is another word for slope. I'm looking at the Y values, which would be number of participants. So let's go ahead and take, we can take that 47.6 million people minus 17.2 million people divided by the number of years. 2013 minus 2000. Just make sure you stay with one piece of data first and then one piece of data second. Simplifying that, use your calculator, simplify that down. You're going to get that that's about, I'm going to put squigglies, about 2.3. Just make sure that when you're doing word problems, you actually make sense of that in terms of what the problem was actually stating. So I'd want something maybe over the 13 years, because 2000 to 2013. So over the 13 years from 2000 to 2013, the participants increased about 2.3 million every year. So just make sure that when you're dealing with a word problem, you really try to, bring it back to the context of what they're talking about. Okay, so example number 4, I'm going to leave that one for you guys to do. Again, when you're reading it, just grab your key pieces of information. So on this one, as you're reading, this looks pretty darn important. This one looks pretty darn important. And then we want to figure out what the average rate of change between those years is. So super similar to what we did before. Look at the graph, try to reason through that one. All right, example number 5. We're going to go ahead and find the slope and the y-intercept of those. So these are already written, or the first one's already written in y equals mx plus b. So very easy to just pull those pieces. The slope on this guy is going to be negative 0.25. The y-intercept, negative 3.8. On the second one, that's also written in slope-intercept, so go ahead and please tell us what is the slope and what is the y-intercept, and we'll check that when you get back to class. Example 6, you need to do a little bit of manipulation, so my hint for you for this guy is to get it, y equals mx plus b. So go ahead and solve for y, and then you'll quickly be able to tell the slope and the y-intercept off of that. So please go ahead and do that one as well. And then example number 7. This guy's talking about predicting height given certain information. So as you're reading through this one, I really like to know, especially when they give us an equation, so we can see that they are already telling us what this equation is right here. But I don't know what m is representing and I don't know what x is representing. So make sure when you're reading through the question, you're really trying to figure out what each piece means. So this is telling me right here the adult height is m. And then it says parents' total height is x. So now when I'm looking at that equation, I know what I'm substituting things in for. So then it says the adult height of females whose parents' total is x can be estimated with that function, and that's the same, this function down here. And the only difference between the two is one has a positive y-intercept of 2.5, one has a negative y-intercept of 2.5, and then we're trying to find the female child height whose parents' total is 135. So we're going to use the female instead of the male, so we're going to use the second equation down here, female height. And remember that x is representing the total parent's height. Well, we know the total parent's height is 135, so this one we're just going to be plugging in that 135 for x use your calculator, simplify that guy, and you're going to get 65 for your answer. So f of 135 is 65. When we plugged in 135, we get out 65. And so that means that that child will grow up to be about 65 inches tall, which is about 5 feet 5 inches. Just so that way we can see in terms of how we would talk about height. And then this one's asking what's the domain. When we talk about domain of just a linear equation, domain would typically be negative infinity to positive infinity. But in this question, that doesn't make sense because it doesn't make sense for somebody to be a negative height, and it doesn't make sense for somebody to just grow forever and ever and ever and ever. So I would like for you to try to think about which heights would make sense. How short could a female be, and then how tall could a female be? So I'm looking for two different numbers, shortest and tallest. So that would be your last piece that I'd like you to look at off of these notes, is try to figure out, and there's not necessarily a right or a wrong answer, just make sure it's reasonable in the context of how tall people are. All right, thanks guys.